I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to welcome Richard Chelminski, head of SDV platform 42 Dot. On today's episode, we'll discuss how 42 Dot is building an end-to-end autonomous driving system. We hope you enjoy this episode. Richard, welcome to the podcast.
Thank you very much. Happy to be here.
It's great to have you here. 42 Dot's been making quite a bit of noise as it relates to the technical breakthroughs that the company's had. And for the audience who's not familiar, 42 Dot is part of the Hyundai Corporation. Well, Hyundai's a big company. They've got lots of different elements in there. They've got the motor vehicles, they've got the heavy equipment, they've got manufacturing. Where does 42 Dot fit into this, I'll call it, impressive, massively large ecosystem known as Hyundai?
So when people think of things like industrial equipment, they're usually not thinking of the most modern of technologies in the universe. And even cars, in some aspects of it, aren't nearly as advanced as some of the cool stuff that we're seeing at CES. So what 42 Dot's role is within this Hyundai ecosystem is to really bring out the modernization of technology into automotive specifically. And per usual for Hyundai, that means sharing it with the greater Hyundai as well.
And you're definitely pushing technical bounds forward. You're following trends in the marketplace because 42 Dot's developed an end-to-end autonomous driving system. That was well done. How did you do it? Let's hear all about the system.
Sure. So it's at least fairly well known now as Atria AI, and it's an end-to-end system with a focus toward that holy grail of level 4 autonomy. The thing I'd like to highlight is that while it is a very, very advanced technology, it really is not being built for the purpose of fleet vehicles specifically. It's really focused on the user for the end product. And so for folks that may not be as familiar, end-to-end takes an approach where rather than having disparate systems that handle different portions of the autonomous vehicle, like one portion that might just be the perception and one portion that might be the prediction and another portion that's planning. What it really does is it takes the data straight from the sensors, it puts it into a large model, and then actually comes out with that planning from it, right? And so we've focused heavily, at least with this latest technology, to go, again, straight from that sensor to planning.
It's smart. So if you look at it from a market perspective, then what you're saying, so then is the plan to compete with Wave and Tesla's FSD, and could we eventually see these in the Genesis vehicles, perhaps, since the company's been very public about making that your technology forward brand?
Yeah, absolutely. So one of the main benefits of using this type of end-to-end camera-focused technology is that it can go into pretty much any vehicle. I'm not going to claim that cameras themselves are ultra cheap. There's a lot to it aside from just the silicon. There's also the lensing, the placement in the chassis, all the wiring to it and things like that. But it does lower the cost quite a bit. For example, the large LiDAR systems that sit on top of vehicles that you might be seeing on Waymos, those can get pretty pricey, as well as not exactly everyone's cup of tea in terms of aesthetics. So when you think about what consumers are willing to buy and focused on buying, cost is a huge factor. Aesthetics are quite possibly the larger factor.
The consumer wants something that blends in. You see the reports out of Austin, the Austinites, the individuals that live there, they don't even realize how many Teslas are going around robotaxi because it just blends in. But if the Waymo, I had a friend that I'll paraphrase what he said, it's like it's a Disneyland attraction. So it really stands out. And the other thing that you highlighted with the LiDAR, not only the increased cost, it's the service cost because they have to be calibrated. If they go in for service, it takes a while, and I believe it's 15 to 30 minutes. It has to drive around to get recalibrated. An end-to-end system doesn't have to get recalibrated, which opens up a massive opportunity for you to put it in personal vehicles and sell more vehicles as part of the Hyundai Corporation. As you clearly said, it's a camera-first system. There is no LiDAR. That's right, no LiDAR, but you do have radar there as part of that. Why technologically was this approach? Because it was scaling, because it could get integrated on the factory line and be a part of the consumer vehicles. Why was this approach taken?
Let's talk about why folks use LiDAR in the first place. So you can kind of think of maybe the Looney Tunes example here. If Wile E. Coyote paints a very convincing enough road on a wall, a camera could theoretically be tricked that the road continues when there's a wall in front of it. Now, I think that's a bit of an exaggeration, but it does effectively hold true, which is that cameras can see aberrations or things that it believes it sees in a given frame or long enough in enough frames, even with disparate cameras, that it could think that there's something in the way or something not in the way when there actually is. So what you really want is to be able to have sensor diversity. When you think of how people drive cars, they're not just looking at the car in front of them and the lines on the road. They're also leveraging sound. If someone's honking down the road, they can hear that. They have intuition based on seeing further as the road might curve, or even looking at oncoming traffic and seeing that they're all braking because they probably saw something and are rubbernecking, right? So there's a lot of sensor input that humans have when they're driving. So not just our eyes, and certainly not just our eyes focused right in front of us. It's a natural thing to go to something like LiDAR because it has a really unique way in which it perceives the world. It's an awesome sensor, throws structured light, captures the reflections, and you get this awesome point cloud data that honestly is practically sci-fi. The light that reflects is a unique type of light, distinctly different from a data set than just the cameras alone. And I know that when you think about how cameras are, it's just light that's getting reflected into these camera sensors. And so thus naturally, it should effectively be the same. But the structured light really gives a lot more information because you get a perspective of how long it took to actually travel there and back. It's a good design for a concept. It also has a higher vantage point for most of these things, as highlighted earlier. But it is highlighted, it's already very expensive and it does take calibrations and it has a lot of maintenance to it. So we understand that cameras alone have certain failure conditions, less than the Wile E. Coyote example, but nevertheless, there are still examples where you can see these types of failure conditions. So you do want some disparate type of data, some distinct data that is different to help assist the vehicle in its ability to understand the world around it. Radar is a really good example of this. It's something that's been around for a long time, and it actually has some cool properties in which how the waves itself propagate around the vehicle. So it might not immediately make intuitive sense, but you can see the vehicle ahead of the vehicle in front of you with radar. It travels along the ground and it reflects it, and you can actually see that secondary reflection at a later date. From a time perspective, they can say, oh, that car is X distance away. And if you can see it braking, then you can intuit that the car in front of you is braking. And it gives that kind of information that a camera alone might not be able to tell. So using cameras first is a great way to save costs. It's a great way to have a very robust system that's capable of handling a lot of different types of scenarios, but you still want to be able to take in some other different types of data to be able to understand the world around you.
Because at the end of the day, your Hyundai motor is you sell to consumers. And I don't see a scenario where consumers going to drive around for 30 minutes to try and calibrate something. They're going to call the Hyundai dealership and read them the riot act, and that's not going to be good for sales. That's truly how it's going to go. On the radar front, should we think about it from a traditional radar perspective, or should we think about it as a more advanced 4D radar? What type of radar are you putting on there? And do you have proprietary software on top of that radar?
We have our own software that we run internal to our vehicle itself. The radar itself is not proprietary in any way. There are a few radars that we're collecting data from to be able to get more data from it, but we're not talking about large radars on the front of the vehicle, and we're not talking about from all different portions of the vehicle. There are different types of technologies around that, close range not LiDARs, close range radars that we're looking to get data to be able to supplement ultrasonics, but those technologies are still pretty young in terms of their use cases.
And so should we think about it for 42 Dots approach of where the radars are integrated into the vehicle design or into the body so they're not looking as an add-on?
Absolutely. All of this technology that we're talking about from 42 Dots perspective is something that we want to bring to every vehicle, whether it's to the higher end Genesis or all the way down to some of the more cost affordable Ionics or even lower than that.
It's fantastic because you're giving all of your customers the ability to experience the future and have a better driving experience at the end of the day. I got to ask you, because this topic there's a lot of heated topics in autonomy, but this one for some reason it's like a ping pong ball and it always goes up and it always goes down. You have the must have LiDAR folks, and you have the people's like, listen, I got an open mind. And these people, they go at each other's throats. why the heck do you, I gotta ask you, why the heck do you think that is, where there could be no middle ground of niceties? It's just, wow.
All right. So in almost every engineering problem, you are going to end up with a stark divide between folks that want to build spaceships and folks that want to build cardboard boxes with four wheels. And it's folks that optimize for every possible scenario of failure, and folks that optimize for what is the bare minimum that we can get by and still make something successful. And you could abstract that and see it play out time and time again. I used to work years ago on a bikes and scooter program, and it was even a more of a challenge. You had folks that wanted to make full motorcycles, effectively e-motorcycles, and then folks that are like, well, what if we basically can take the battery out? And then you're saying, well, it's just a bicycle. So this type of ideological divide is just present in the process of engineering, and people have their strong feelings about what is a level of safety they're willing to accept, what is good enough, what bells and whistles should there be. And there's no question LiDAR can see more. But there are downsides to it, right? As with every single decision that gets made in a vehicle, there are pros and there are cons. There's nothing that you just get for free.
And I'll give a public example. 42 Dot, you put out a YouTube video of showing an autonomous drive. And if the audience wants to see, it was right there in the comments section. That's the comments section, but I focused on the video. I gotta say, I was impressed. How long did it take from an engineering perspective to be able to achieve that demo? And are you still actively running tests that you disclosed publicly in that YouTube video?
Sure. So I can at least answer some of that. 42 Dot has been around, I think, since, I might be misspoken here. I think it's 2019 or 2020. It was before I joined the organization. And they were focused on AI first. So it's been a number of years that they have been developing. Obviously, this wasn't something that we developed 5 years ago and then just showed now. And it also isn't something that we have been developing entirely that entire time, and just now we're able to release a YouTube video, right? There have been a lot of iterations, and we continue to iterate on it as we go along. But if the question really comes down to what we saw in the video, is that something that gets tested a lot? Yeah, we're able to go even more than what we had shown in the video. It was just a very attractive video to be able to show and demo some of the technologies that we currently have working, and we have gone beyond that as well.
That's fantastic. Where would you say 42 Dot is today, the commercialization scale? Is it still an R&D shop, or are you getting closer to potential integration? Where would you say you are on that development life cycle?
We are currently looking at commercialization for the product actively on vehicles. I can't give specifics, unfortunately, because that really goes into the product strategy where I try to stay a little bit out of. But it's an active discussion and development about exactly which vehicle line it will go into. So it's far enough along that we think we can utilize it. We have a similar approach to other OEMs from the perspective that we think that we can also release it with the right amount of sensors and then continuously improve and advance it so our customers can get better experiences as they have ownership of their cars.
That's fantastic. I mean, you have the plant in Savannah, Georgia, which your Ioniq 5s, the robo-taxis for your customers are coming off that, and that's doing very well for you. When we think about 42 Dot, should we think about it from a global perspective where perhaps vehicles are available in Korea, they're available in the United States and other markets? Should we think about it as a potential global rollout for this technology gets integrated into the vehicles on the line?
100%. The goal is global. It's not just focused on Korea development.
As you mentioned earlier, there's a lot going on inside of the Hyundai Corporation, but in Hyundai Motor Corporation, there's also a lot going on. You have your division 42 Dot and you have Motional. How do you complement each other, or what's that dynamic or relationship like?
I'll be completely honest. I don't think the question is fully answered yet. And I can't go entirely to the inside baseball of it, but there are significantly different markets for these organizations. And that may just be based on the sensor suite choice as well. There is a consistent idea within the advancement of vehicles referred to as CASE or CASE, and the third character of that is shared. right? So the second one's autonomy, which is certainly what's focused on for 42 dot Motional. But that third one, shared, is something that is becoming more prevalent, but the exact user story for that hasn't really been discovered. So when you think about 42 dot, it's mostly camera focused, and Motional certainly has been seen with LiDARs on their systems as well. And I don't want to talk too much about what Motional is doing, but there's a disparate sensor selection between the two.
I think it's if you look at it from my perspective, from an outsider perspective, I could see a really interesting scenario. Let's just use the Ioniq 5 because you're very public with those, where I own an Ioniq 5 as my personal vehicle, and perhaps I buy a Hyundai mobility pass and I get to use the Motional robotaxi in certain cities. That's interesting. I could see that complementing each other. Am I way off my rocker, or there might be a little bit of grain in there?
I think that organizations the size of Hyundai Motor Group are able to pull a lot of these different technologies that they're investing in together to make sure that the customer has the best experience they have. There are a lot of different subsidiaries that make up these organizations, and the end product of seeing the vehicles is it would appear to just be a Hyundai product, but is in fact all of these subsidiaries working together to be able to give the customer that experience.
The bottom line is Hyundai's investing in the future of autonomy, and as part of the investments for 42 dot, they funded and you built a proprietary operating system. That's impressive. Why build your own operating system?
Let's clarify what operating system means in this context. We are not building a POSIX system from scratch, as an example. But if you look at something like Android, it has a Linux kernel inside of it, and then it's a lot of tools and APIs on top that make it the experience that everyone uses and helps application developers serve their customers what they want. What we're building is the same concept. It's a lot of tools and engineering designs to be able to enable modern concepts like AI in the vehicle to serve customers what they want to be able to have. Vehicle is a very, very complex thing. And being able to unlock data in a tangible way for our customer base is what building this operating system enables.
If you're enabling AI in the vehicle, should we think about like an 11 labs perspective with voice, or should we think of predicting things? How should we think about AI inside of the vehicle?
Sure. Maybe it's a bit of a cop out, but we'll say that is in all of the above. Yes, voice is an important part of it. Voice has an interesting density dynamic. And what I mean by that is if I were to say something like, Hal, open the pod bay doors, that is a lot longer to do than for me to hit the pod bay doors button. But if I say something like crack the windows, it's actually quite a bit of information. One is it tells us how much the window's open. It says all of the windows at one time. And being able to do that then would actually take me pushing 4 buttons in sequence or having to hit each of those and crack the windows individually, unless, for example, there was a crack the windows button. But these types of dense operations can be done very quickly with something like an AI that can intuit the context for it. But just the voice portion is not alone what AI is. It's also understanding the customer over time, being able to build out profiles for them, being able to build out more information density for other visualizations for the customer, as well as the long-term maintenance for the vehicle as well.
Maintenance is key, but you said something interesting for preferences. Let's just say it's, 77 degrees out, and then the vehicle knows, okay, Richard likes his windows cracked at 77 degrees outside. It opens it up because that goes in that consumers want, they don't want to have to think, they want prediction. Could that be coming?
Yeah, absolutely. All of these types of technologies are being actively worked on and discussed as well. What will show up in the vehicle, I can't say, but these concepts aren't, once you have the actual system working as we're discussing, it's really not that challenging to add these features in context-aware operations.
Should we think about adding features in the vehicle as, if you want to use Lego block, you're adding on another Lego block, adding on another Lego block, let's call it, for simple terms, let's just call it Hyundai OS, for example, and you can just continue to add features on, or if I use a technical term, to plug in new features. Is that how we should think about that?
Yeah, absolutely. We can dip into what I think most people now call the software-defined vehicle a little bit, and what that really means. I have a certain perspective. I think everyone has a different perspective about what software defined really means. For me, it really means that software is a larger stake during vehicle development. If we go back 20 years, software was just something that you put into the vehicle after you've already designed the mechanics of it and the electronics for it. Nowadays, it has a much larger stake at that table when you're talking about, well, what features do we want this vehicle to be able to do? Suddenly you have things like, well, it certainly has to be able to be locked and unlocked from my phone app while I'm in a movie theater. And these features need to be developed both during the initial creation of the vehicle, as well as to have some perspective growth in the vehicle as well, meaning that we know that we can develop this software and deploy it. And so we also have to perceive and estimate what will possibly be used on this vehicle, or what the vehicle will be used for, I should really say. And so you have to budget for that. You have to be able to plan at least proactively to say, okay, we should really make it capable of these 5 things, even if at launch it won't do that. We know it's a customer desire. And so software defined as a secondary part is that the vehicle, when you get it that first day, is in the least feature rich state that it will be in your total ownership. Over time, you're able to get more and more features as continued development happens on that vehicle, as well as on future vehicles that you basically reap the benefits of.
The consumer wants the vehicle to get smarter, not dumber over time. The no update days, those are long gone. That vehicle better be getting updates and the consumer be getting satisfaction. When from an engineering team is sitting down and they say, the order comes from Korea, okay, time to develop new car. And obviously you bring the traditional engineers and the architects and the designers and all this. Is software now the defining lead in those conversations? Does it all start with software?
I don't think I would say that it all starts with software. As I spent most of my career writing software, so there's a bias I personally have of its importance, but I think really the first thing is that you need to understand the type of car you're building, because consumers tend to have a desired vision for what they want, not necessarily the exact aesthetic, but you are not going to buy a sports car and end up with a minivan. There's generally a size, a shape, a number of seat configurations and things like that. How far you think it's going to be able to travel on a charge, what its kind of mileage is capable of handling, its reliability, things like that, the speed of it. So those classical concepts of cars that have been part of the development for a long time still exist. The real important thing is that beyond 4 wheels and how fast it can really go, you start to ask, well, what else can it do and should it do? What are customers asking for? What can phones do today that people are going to be starting to expect in our cars? And that's when the software question really starts to come in. And what that manifests as is semiconductor choices and the bandwidth expectations on the wire within the vehicle. And it starts to say, yes, there is a vehicle there, but inside of the vehicle, when you do the architecture for it, it starts to look closer to either data centers or cell phones, depending on different architecture choices.
And then at that point, those conversations, is that where the RAM and the compute and the power conversations enter the picture? Oh, you want to build this whole thing, but wait a second, we only have X amount of power, so we have to have some optimizations or trade-offs there?
It's a massive balancing act, right? It's if you put 128 gigabytes of RAM inside of that vehicle, 128 gigabytes of RAM will suddenly get used up by all of the engineering team overnight. So it's always a balancing act of trying to understand what can be built today based on what you've already built yesterday, and then what you think that you'll be building tomorrow. And so there's always constraints because, again, like I talked about earlier, there's the engineers that want to build spaceships, and then there's the engineers that want to build a cardboard box with 4 wheels, right? And so this is one of the many problems is, well, how much RAM, how much flash, what is the, what's the latest processor that just came out? Can we throw that in there? And those questions get asked, and you have to have at least some maturity to say, okay, maybe not the absolute latest, because that may not be as important for this level of vehicle and how long we plan to be able to maintain it, and what features we expect to have it. Because truthfully, you can always just kind of squeeze the code on a little bit more and optimize a little bit better and do a little bit better engineering, because constrained engineering makes better products.
That's right. And then there's the next ingredient to come into this, wiring. Is that the next ingredient to fall into this pie?
Wiring is it's a very big problem, and it's a how best to put it. Wiring is the interconnect, obviously, between all of the different components in a vehicle, and vehicles may have upwards of hundreds of components, and they may nowadays have less than 50, really depending on kind of the size of the vehicle and how many types of sensors and where they need to be throughout the vehicle. What we're seeing now is that the network buses, not the single I/O channels and things like that throughout the vehicle, but the network buses are getting far more dense from the perspective of bandwidth, right? So maybe 10 years ago, CAN was the de facto standard for a lot of the wiring buses. But as we get more intelligence at edge, those sensors become far more dense in terms of what it's capable of pushing for data. You need to be able to supplement your vehicle's wiring with more capable buses. So you're seeing Ethernet or even new technologies like CAN-XL that's again still being sorted out as to which one's going to really win that fight. But nevertheless, you're seeing much higher bandwidth throughout the vehicle to enable this type of information sensor. And the each given ECU or circuit board throughout the vehicle is becoming more intelligent. And it in part is because we have all this data that's coming into it, and in part because semiconductor companies have really been able to create some impressively cool technologies.
You take higher bandwidth, more intelligence, and you take the traditional automotive of your tier suppliers. How do you get all of this to work together or orchestrated? Did you have to write a special software layer? How are you getting all that? Let's call it the traditional and the non-traditional and the rocket ship engineers to we gotta work all together at the end of the day. How do you get it all to come together?
It is challenging. I won't deny that. On a component side, you really have to have a lot of self ownership over this. And when I say self ownership, I mean you need to be able to, the vehicle engineering needs to be able to also help dictate the software stacks that get utilized and the amount in the hardware design that gets put into it, right? Instead of just saying we need a black box that can connect these 5 wires out, you suddenly start having to say, okay, well, now they're just buses, so the actual wiring is done in software. And we absolutely have built a lot of software to be able to handle pushing this data to the correct places efficiently and safely. If you just look at technologies that exist in the world and pushing packets from one spot to the other, it happens at very high reliability throughout the world, right? We have the internet. I don't think anyone's contesting that it's a very unreliable medium by which we can push data. But the important thing to note is that it's a slightly different data set. Yes, we still might be using TCP/IP, but we also have to guarantee that the packets from your inverter manage to be able to get to your centralized ECU consistently and within a time allotment that allows for being able to react safely enough, even for things like a minimum reaction for an ADAS event and things like that, right? So this data needs to really be put in the right location at the right time so it can be adequately reacted to. And that really does require rethinking how you push data around. And when we do this, it means building out a lot of custom software.
And I mean, you said that the end software. What would you say percentage-wise from a 42 dot employee perspective? Are the majority of them software engineers that are in the organization now? Is that the majority of the organization?
Yeah, without question.
Yeah, I mean, at the end of the day, the future of autonomy comes down to software, and 42 dot is building great software, and there's public videos to back up that statement. Richard, as we look to wrap up this insightful conversation today, which has been awesome, by the way, what would you like our listeners to take away with them?
The world of automotive has changed a lot in the last 10 years. There are a lot of factors to that, but I think most importantly, it's the devices that we play with outside of the vehicle, like phones and laptops, that have pushed semiconductor companies to create some wild technologies like neural processors. And these technologies are even making their way down to microcontrollers. In turn, these advances external to the automotive segment mean that we have to also advance with them. We have to change and adopt these technologies and give customers better experiences that integrate into their more technologically advanced life. And the end result is automotive companies like Hyundai that are investing in their self-owned and from scratch software in components that can enable things like, deployable autonomy updates that improve over time.
Everything's things going to improve over time, and soon the watch is going to play a very large role in all this, and glasses as the phone hopefully goes away for the betterment of society, but that's a whole conversation for another day. Today is tomorrow, tomorrow is today, the future is 42. Richard, thank you so much for coming on SAE Tomorrow Today.
Thank you very much for having me.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
Be sure to join us next week as we explore the history of ground vehicles, the SAE standards behind them, and how you can help tell that story and get involved.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.